Hello there, math folk. We are going to jump into the very first unit in my geometry class, and I'm going to start off with a joke. What did the acorn say when it grew up? Geometry. All right, so this is the first segment we're going to get into, and it's going to be about points, lines, and planes. And what we're going to do is tackle these particular exercises here, and we're going to build some vocabulary, and we're going to look at how we view perspective of shapes and how they're named, and diagrams and all sorts of stuff. And we'll get through the lesson that way. This particular lesson again is about points, lines, and planes. So when you're looking over the questions about naming two intersecting lines. Name the intersection of planes QRBA and TSRQ, and three non-collinear points. Of course, we're going to have to know what all of these words mean, right? So just looking at these first three questions, we got to know what intersecting means, what lines are, and what planes are, and what points are, and whatever that word is, by the way, pronounced collinear. So we're going to have to dig into some knowledge. And to do that, well, I'm just going to slide the textbook over a little bit. I'm going to help you walk through this textbook, right? So just a quick review of this particular lesson with points, lines, and planes. So what's a point? Point indicates a location and has no size. What? What's that all about, cats? So let's take a look. What's a point? It's a point. Ta-da! Point. All right, now this particular point looks like it has shape, right? Like a circle. But that's not exactly what a point is, because a circle has a shape. A circle has a measurement. A point has no measurement. Okay, you can't measure a point. Cannot measure a point because it's just a location. So you can't measure a point, it's just a location. So this particular dot actually has a measurement, but we're just going to use it. So a point indicates a location, it has no size, and normally when we make a point, we label a point. So another note, always label points, right? Now, the most common label for points are the alphabets, okay, so letters. In particular is letter A. You will mostly find letters as label for points, so that's a point. Now, what's a line? Okay, a line is represented by a straight path that extends in two opposite directions without end and has no thickness. What? So that's crazy. So how does a line get born? So let's go back to the whole thing about a point, right? So if we have a point that exists here, and remember a point has no measure. You can't measure a point. It's just a location. Well, if I invented another point, let's call another point here, I'll call it B. Well, now what we can do is we can create or give birth to a line. So a line extends in two opposite directions, no end. Okay, so it extends in two opposite directions, has no end. So it can go through those 2 points, A and B. Okay, so now we have given birth to a line. Right? Now, a line you can't measure either because it has no end. So you can't measure a line. It has no end. Okay, so cannot measure a line because it has no end. Right? Does that make sense? I hope so. So a line can be born extending through 2 points. Okay, and it has no thickness. So the line has no thickness, even though this particular line has this thickness. In concept, it has no thickness. So you can like zoom in on this particular picture. It would have a thickness, but really it doesn't. So what's a plane? A plane is represented by a flat surface that extends without end and also has no thickness. So a plane as well has no thickness. So where does a plane come from? We can give birth to a plane. We can create a plane with a third point. Okay, so a third point can make a plane. And to demonstrate that, I'll use a blank thing. So a third point that is not on the same line can create a plane. So we normally represent a plane by using a perspective of a diagram. You know, two-dimensional looks like a parallelogram, but you got to picture, you know, this is like a piece of paper, although this is a plane segment. It's not because the plane extends forever. But this is what it would look like. So that third point creates a plane. So that's what a plane is, right? So we have to know that vocabulary. The simple point has no measure. It's a point. A line is in two opposite directions going on forever. Also can't measure it. And a plane goes in every direction. Also cannot measure a plane. So that's the thing. And a plane could look like this. It could look like this, right? So the plane could look, can go in any direction. Here's my name badge, right? So a plane could be here. The plane could be here, going on in any direction, right? So the plane can go on in any direction forever and ever and ever and ever. Has no end. So we also can't measure a plane. All right, so we got to know those concepts. 1 point makes a point. 2 points makes a line. 3 points, as long as they're not on the same line, make a plane. All right, so 1 point is a point. 2 points can make a line. And 3 points, as long as they're not on the same line, and we call that collinear. Yeah, go vocab. 3 points not collinear make a plane. All right, so we have to know that particular concept. Points, lines, and planes, right? Now, points that, here we go back to the vocabulary, back to the textbook. Points that lie on the same line are called collinear points. Okay, so that was the vocab we just did. On the same line, collinear. Points and lines that are on the same plane are called coplanar, on the same plane. Segments and rays are parts of lines. And so we'll get into that in a second. All right, so let's take a look at these particular notes that's from the textbook. We're going to name all the segments and rays in the figure. So what's a segment? Okay, a segment is basically a cut-off chunk of a line. So I'll call it that, the chunk of a line. So if you have a line here, it's a line AB. Let's say this is A and this is B. And that's a line. So a segment is a chunk of that line. And the chunk of that line is determined by endpoints. Okay, so we have an endpoint A and an endpoint B. That's the chunk of line. And now we have a segment. Okay, so now we can have a segment here. Okay, so there's your segment. That's a segment. Cool? I hope so. That's a segment. I'll get into naming things in a second. Okay, now what is a ray? Well, that's interesting. A ray, then, is pretty much like half a line. It's not a chunk of a line. It's like half a line. So we can call that a ray. Half a line. How's that for vocab? You like that? Beautiful. So if we start, again, I'll use different letters just because. How about J, K? So we have a line JK, right? A ray is half that line. What does it mean, half a line? Lines don't have any measure. You can't take half a line. I'm just saying. Let's say, boom, now I have a ray there. Okay, so I could have a ray if I start with one endpoint. All right, so rays have one endpoint. Boom. All right, so if I had JK, that's a ray. And I could also have this one, right? I could also do this one, JK. Those are two different rays, by the way. And again, we'll get into naming stuff right about now. All right, so we can name things, right? Stuff has names. So how do we name things? Okay, let's go into naming. So now we're going to talk about naming. How do you like my handwriting? We're going to talk about naming stuff. To name a line, we use this little deal, right? That little deal. To name a ray, half a line, we use this little deal. And then to name a segment, a line segment, we just use this little deal. Okay, so we got to know that. That's some serious vocab right there. So we have a line, a ray, and a segment. Okay. So how does naming work? Naming all depends on how you are reading. Okay, so the naming of things depends on how you read it. So you can have multiple correct ways to name things. It all depends on how you read it. All right, so if you look at the line that we drew earlier, remember this line? We had A, B. So if you look at that line, if you're reading it from left to right, then that line would be called line AB. That is a correct name. But that's only if you're reading it from left to right. If you read it from right to left, that line can be called BA. Okay? But that's only if you're reading it from right to left. If you read it from left to right and call it BA, you're not correct. I won't know because I don't know what you were thinking when you said BA. But if you read it from left to right and you call it BA, that's not correct. You need to call it AB. If you read it from right to left and you call it AB, that's also incorrect. If you read it from right to left, it's called BA. So it all depends on how you're reading it. Same thing with the line segment. Okay, if you're reading the line segment from left to right, that line segment is called AB. And if you're reading that line segment from right to left, that segment is called BA. Both are correct names, but it totally depends on you and how you're reading it. If you read it one way and call the other, you're technically incorrect. I won't know, but only you will. So make sure you're tracking your brain. Now, where does that come into play? That comes into play with rays. Rays can actually only have one correct name. So lines can have two correct names. Segments can have two correct names. Rays, on the other hand, can only have one correct name. So this particular ray here, this first one, can only be read from left to right. It can only be read JK. Okay? So that is the only correct name for that particular ray. It cannot be called KJ because it's not going that direction. This ray down here, that can only be correctly named in one way. It can only be read from right to left. So this ray is called KJ. There's only one way to read a ray. Oh, that sounds like a cool note. Only one way to read a ray. Okay? Okay. Now, that's how you read lines and segments and rays. So what about planes? Can you read planes? Yeah, you can read planes a whole bunch of different ways. But we'll get to that in a little bit later. Let's go back to the notes here. So in this example that's in the textbook here for this particular problem, we're going to name all of the segments and rays in the figure. Okay? So if you look at the segments, we got segment AB. Now, where would segment AB be? You look at the picture. Segment AB is right here. But that's only if you're reading it from A to B. If you read it from B to A, it's going to be called BA. But it's AB here. And AC is also a segment, right? So AC is a correct segment because you can read it from A to C. Or you can also read it from C to A. Okay, that's also correct. And then BD is a segment as well as DB. Those are the only segments. Okay, so how many segments do we have? We have 4 segments. We got AB, AC, BC as well, or CB, and DB and BD. Okay, so all the same thing. So this one, this one, this one, and this one. Okay, so those are all correct segments. Now what about the rays? We have a bunch of different correct rays. So check this out. We got this ray here, BC, that's a ray, and BA is a ray. Notice there is no ray AB. Okay, there isn't a ray AB, or is there? Yes, there is, because this ray goes from here. If we ignore this particular thing, now we have a ray going from A to B. We also have a ray going from A to C. Okay. So notice one thing. Is there a missing ray? Is there a ray that's missing? So we have BA, BC. We've got AC, CA. Okay. We have CB. We have BD. But do we have a ray going from D to B? Okay. Can we have a ray DB? So what about? Oops. What about ray DB? Can that exist? Not on this picture. It does not, because B is an endpoint. There is no ray DB. Excuse me. So that can't happen. All right. Okay, so far so good? Good. So back to these problems here. So the original problems we have, okay, name two intersecting lines. You have many different correct answers for this. Although I would like to correct the question. I don't like the question. Name two intersecting line segments would be better, but still. What does intersecting mean? Okay, so intersecting means crossing. Okay, so intersecting means crossing. So any two intersecting lines. It could be AQ and QR. It could be RB and BC. It could be like through the back, DC and DA. So many intersecting lines that you could write. Okay. But the first things first. How do you know this is a three-dimensional figure? Because the dotted lines. Okay. Dotted lines means it's three-dimensional. So we have to remember that as well. What do dotted lines mean? Dotted lines mean it's three-dimensional. That's with an S. Pardon my spelling. Three-dimensional. Okay, so we know this is 3D because of those dotted lines. So there's depth to it, and all of those lines can intersect. TD can intersect with TQ. There's so many different correct ways, but it all depends on how you're reading it. You must keep track of your thinking. Okay, you must keep track of your thinking. That's so important. You understand? I hope you do. So keep track of your thinking. Critical. Name the intersection of planes QRBA and TSRQ. QRBA is a plane. So notice that three-dimensional figure. That's the face facing you. That's QRBA. So notice we read this. QRBA, QRBA. That's this face here. Okay, so there's one plane. The second plane, TSRQ. Well, here's TSRQ. The second plane is the top box. Okay, so we have to make sure you know how to read stuff. QRBA, QRBA, and TSRQ, TSRQ. So we read things in order. And where do those two planes intersect? They intersect at the corner here, this corner. So where do they intersect? They intersect at QR or RQ. Both are correct. Okay, so there's only two correct answers for number 8. It could be RQ or QR. Name three non-collinear points. Any three non-collinear points, not on the same line. All right, so it could be Q, R, and S, not collinear. In fact, there are in this picture, you won't find three collinear points. Okay, so the answer for number 9, in this picture, there are no three collinear points in the picture. That's crazy. So any 3 points you name are going to be correct. Okay, so there are no 3 collinear points in that picture. So make sure you understand that. That's all that jazz, right? Okay, so for the next one, number 10, we're going to do some true and false. So number 10, we are saying that 2 points are always collinear. Well, is that the case? So number 10, are 2 points always collinear? Well, let's test some stuff out. It's going to be important to test this out. So let's do a test to see if we can create or visualize 2 points that are not collinear. Okay, so let's test 2 points out. Will they always be collinear? Well, let's say I have a point here. We'll call it point Y, and a point here that would be a point Z. Well, if I just stop at those 2 points, that's going to be collinear. There'd be a line going through there. All right. So what if I had a point in space here, Y, and another point in space here, Z? That would be collinear. Oh, darn it. Let's see. If I had another point here, Y, and maybe a point here, Z, and that would be collinear. It seems to be that I cannot even visualize any 2 points that won't be collinear. So number 10 happens to be true. Okay, number 10, true. 2 points are always collinear. Isn't that cool? True. 2 points, always collinear. So number 11, how do you even read that? Like number 11, I don't even know how to read that. So here's how to read number 11. Okay, read number 11 by first. The first thing out of your mouth should be Ray L M. That should be the first thing out of your mouth. Ray L M. That's how you read that. Ray L M. And then the second thing is going to be Ray M L. Okay, so how do you read those two things? You have Ray L M and Ray M L. So the question is, Ray L M and Ray M L are the same ray. Is that true? I don't know. Well, let's test some things out. Okay, so remember we had two things, Ray L M and Ray M L. We can actually draw Ray L M. Remember how we name rays? We have an L and an M. Ray L M looks like this. That's Ray L M. Ray M L, if we have the same 2 points, Ray M L, remember how we read rays. We read rays from the endpoint. So this is ML, it's going to go this way. There's no other way to draw Ray ML. That is it, dudes. That's it. So guess what? They are totally not the same ray, right? Not the same. And if they're not the same, that statement, of course, is false. Okay? So that's what the questions are going to look like for this concept. Okay, when you encounter questions of your knowledge for this thing, that's what the questions are look. They look just like this, but most importantly is reading stuff. Okay, so how we read this? Ray LM. And how we read this? Ray ML. And you can draw that stuff. And that's the intro to points, lines, and planes. I think I'm out. Peace. Enjoy your homework.